It's me, Teacher Jeanne. In this lesson, you will learn about simplifying rational algebraic expressions. In this lesson, we need to recall about factoring polynomials. First, we have common monomial factoring or CMF. Second, difference of two squares or DOTS. Third, perfect square trinomial or PST. Fourth, sum of two cubes or SOTC. Fifth, difference of two cubes or DOTC. Sixth, the general trinomial of the form x squared plus bx plus c where a is equal to 1. And for the last, we have the general trinomial of the form ax squared plus bx plus c where a is greater than 1. We also need to recall the laws of exponents. We have the product rule and the quotient rule. In product rule, we copy the same base and add the exponent. In quotient rule, we have three cases. First, when m is greater than 1, we copy the same base on the numerator, then subtract the exponent. Second, when m is less than n, we have the numerator 1, then copy the same base on the denominator, then subtract the exponent. And for the last, when m is equal to n, we copy the same base and subtract the exponent. Now, as you notice, the difference of the exponent is equal to 0. Any number or variable raised to 0 is equal to 1. Simplifying fractions. A fraction is said to be reduced to its lowest terms when the greatest common factor or GCF of its numerator and denominator is 1. To reduce a fraction to its lowest terms, first, find the GCF of the numerator and denominator. Second, divide both the numerator and the denominator by the GCF. Now, for you to understand, let's have the following examples. First, we have 14 over 21. Here, we're going to use the prime factorization. So, 14 is equal to 2 times 7. 21 is equal to 7 times 3. And we're going to align the common and encircle it so the greatest common factor is 7. Then, we're going to divide both numerator and denominator by the greatest common factor, which is 7. So 14 divided by 7, we have 2. 21 divided by 7, we have 3. So we have the lowest term, 2 over 3, or 2/3. Second, we have 5 over 15. So 5 is a prime number. 15 is equal to 5 times 3. Align the common and encircle it. So we have the greatest common factor is 5. Then, divide both numerator and denominator by the GCF. So, 5 divided by 5 is equal to 1. 15 divided by 5 is equal to 3. So, the lowest term is 1 over 3 or 1/3. For number 3, we have 24 over 36. So, the greatest common factor is 2 times 2. 4 times 3 is 12. Instead of dividing the numerator and denominator by the GCF, we can also write the product of the factors with the greatest common factor, which is 12. So we have 2 times 12 all over 3 times 12. Then we apply cancellation. 12 divided by 12 is equal to 1. Then multiply the remaining on the numerator and also on the denominator. So any number or variable multiplied to 1, the result is the number. So it gives us 2 over 3 or 2/3. For number 4, we have negative 12 over 9. The greatest common factor is 3. Write the product of the factors with the GCF 3. So we have negative 4 times 3 all over 3 times 3. Apply cancellation. 3 divided by 3 is equal to 1. So it gives us negative 4 over 3 or negative 4/3. It's considered improper fractions, so we need to change it into mixed number. So divide 4 divided by 3. The result is negative 1 and 1/3. For number 5, we have 56 over 100. For bigger or larger number, we can use the ladder method. Then multiply the common divisors. We have 2 times 2. The greatest common factor is 4. Then write the product of the factors with the greatest common factor 4. So we have 14 times 4 all over 25 times 4. Apply cancellation. 4 divided by 4 is equal to 1. And any number or variable multiplied to 1, the result is the number. So it gives us 14 over 25. For number 6, we have negative 126 over negative 312. Negative divided by negative, we have positive. Then again, for bigger or larger number, we can use the ladder method. Then multiply the common divisors. We have 2 times 3. The greatest common factor is 6. Then write the product of the factors with the greatest common factor 6. So we have 21 times 6 all over 52 times 6. Then apply cancellation. 6 divided by 6 is equal to 1. So it gives us 21 over 52. And 21 and 52 have no in common, therefore that is the lowest term. Rational algebraic expression is a ratio of two polynomials provided that the denominator is not equal to 0. It is written in the form a over b, where b is not equal to 0. The line there is what we call the fraction bar that denotes division. A is a polynomial and B is also a polynomial. So we have the ratio of two polynomials. When B is equal to 0, the expression is considered undefined. Simplifying rational algebraic expression. A rational algebraic expression, or RAE, is in its simplest form if there is no common factor in the numerator and in the denominator except 1. To simplify a rational expression to its lowest terms, first, we're going to factor the numerator and denominator completely. Second, divide out or cancel all common factors. Third, multiply the remaining values in both numerator and denominator. For you to understand, let's have the following examples. For number 1, we have 6x cubed over 9x. So first, we're going to factor the numerator and denominator. Here, we can write it in the expanded form. For the numerator, 6 is equal to 3 times 2 times x cubed is equal to x times x times x. Then, for the denominator, 9 is equal to 3 times 3 times the variable x. Then, divide or cancel out all common factors. So 3 divided by 3 is equal to 1, x divided by x is equal to 1. Then multiply the remaining values in both numerator and denominator. So here we can apply the product rule on the variables. So 1 times 2 times 1, still we have 2. Then x times x, we copy the same base, x, then add the exponent, so the result is x squared. Then the remaining on the denominator is 3. So the simplest form is 2x squared over 3. For the other solution, we can have also 6x cubed over 9x. We can get the greatest common factor of the coefficient or constant of the numerator and denominator. So the greatest common factor is 3. Then, we can divide 6 divided by 3 to 9 divided by 3, we have 3. Then, for the variables, we can apply the quotient rule. We copy the same base, then subtract the exponent. Then, multiply the remaining values in both numerator and denominator. So, still we have the simplest form, 2x squared over 3. Another way is, still we can cancel 6 divided by 3, we have 2. 9 divided by 3, we have 3. Then x cubed divided by x, we have x squared. When we apply the quotient rule, then multiply the remaining values in both numerator and denominator. So 2 times x squared, we have 2x squared over 3. So in any method or in any way, we come up the same result. For number 2, we have the given 8wx cubed y to the 4th z squared all over 12wxyz. First, we can get the greatest common factor of the coefficient or constant of the numerator and denominator. So we have 8 and 12 and the greatest common factor is 4. Then, we can divide or cancel out all common factors. On the coefficient 8 and 12, we can cancel 8 by dividing it with the greatest common factor, which is 4. So 8 divided by 4, we have 2. 12 divided by 4, we have 3. Then for the variables, we can apply the quotient rule. W divided by W is equal to 1. X cubed divided by X, we have X squared on the numerator because the exponent 3 is greater than 1. Then y to the 4th divided by y, we have y cubed on the numerator because the exponent 4 is greater than 1. Z squared divided by z, we have z on the numerator because the exponent 2 is greater than 1. Then multiply the remaining values in both numerator and denominator. So on the numerator, we have the remaining 2 times 1 times x squared times y cubed times z. Then on the denominator, we have the remaining 3. So the simplest form is 2x squared y cubed z all over 3. For the other solution, we can have here, okay, the product of the factors having the greatest common factor, which is 4. So if you're going to factor 8, that is 2 times 4. Then 12, that is 3 times 4. Then cancel the common factor. 4 divided by 4 is equal to 1. Then on the variables, we apply the quotient rule. W raised to 1 minus 1, that is equal to W raised to 0. And any number or variable raised to 0 is equal to 1. So still, we come up the same answer. We have 2. So subtract the exponents. We have x squared y cubed z all over 3. So in any method, we come up the same answer. For number 3, we have negative 9a cubed bc squared all over 15ab cubed c. First, we're going to get the greatest common factor of the coefficient or constant of the numerator and denominator. So we have 9 and 15, and the greatest common factor is 3. Then we're going to divide or cancel out all common factors. For the coefficients, we're going to divide negative 9 with the greatest common factor 3, and the result is negative 3. 15 divided by 3, we have 5. Then for the variables, we're going to apply the quotient rule. So a cubed divided by a, we have a squared on the numerator because 3 is greater than 1. B divided by b cubed, we have b squared on the denominator because 3 on the denominator is greater than 1 on the numerator. Then c squared divided by c, we have c on the numerator because the exponent 2 is greater than 1. Then multiply the remaining values in both numerator and denominator. So on the numerator, we have the remaining negative 3 times a squared times c. Then on the denominator, we have the remaining 5 times b squared. So the simplest form is negative 3a squared c all over 5b squared. For the other solution, we can write the product of the factors of negative 9 and 15 having the greatest common factor 3. Then cancelled out 3 divided by 3, that is equal to 1, and apply the quotient rule on the variables. And we come up the same result, negative 3a squared c all over 5b squared. For number 4, we have 2x plus 4 all over 5x plus 10. So first, factor both the numerator and denominator completely. So in 2x plus 4, the common monomial factor there is 2. So we have 2 times the quantity of x plus 2. Then for the denominator, the common monomial factor on 5x and 10 is 5. Then divide each term with the common monomial factor 5. 5x divided by 5, we have x. 10 divided by 5, we have 2. Then divide out or cancel out all common factors. So we have there the common binomial factor. Same first term and same second term. So x plus 2 divided by x plus 2, that is equal to 1. So the simplest form is 2 over 5. For number 5, given y squared minus 25 all over y minus 5, we're going to factor both the numerator and denominator. Y squared minus 25 is considered the difference of two squares, or DOTS. So the factor is the quantity y plus 5 times the quantity of y minus 5. Then for the denominator, y minus 5 is already a prime, so we just copy it. Then divide or cancel out all common factors. So as you can see, we have there the common binomial factor. Same first term, same second term. So we're going to cancel y minus 5 divided by y minus 5 is equal to 1. Then multiply the remaining on both numerator and denominator. On numerator, we have the quantity y plus 5 times 1. And the remaining on the denominator is considered 1. And no need to write it. So the result is y plus 5. For the final answer, no need to write the parenthesis. So parenthesis is used only if there is a remaining terms to be multiplied on y plus 5. So take note, in rational expressions, cancel only the common factors, such as common monomial factor, common binomial factor, or common trinomial factors. For number 6, we have 3x plus 21 all over x squared plus 8x plus 7. So first, factor both the numerator and denominator. In the numerator, 3x plus 21, the common monomial factor on 3x and 21 is 3. Then to get the remaining, we're going to divide. 3x divided by 3, we have x. 21 divided by 3, we have 7. Then on the denominator, that is considered a general trinomial in the form x squared plus bx plus c, where a is equal to 1. So we're going to factor 7, whose sum is 8. So we have the factor of x squared is x times x, and the factor of 7 is 1 times 7. If you're going to add, we have the coefficient of the middle term, which is 8. Then divide or cancel out all common factors. So we have the common binomial factor, x plus 7 divided by x plus 7 is equal to 1. Then multiply the remaining. 3 times 1, we have 3 over x plus 1. Then for number 7, we have x squared minus 10x plus 25 all over 25 minus x squared. First, factor both the numerator and denominator. So x squared minus 10x plus 25 considered a perfect square trinomial. So the factor is the quantity x minus 5 squared. The square root of x squared is x, and the square root of 25 is 5. If the middle term is minus, the operation of the square of binomial is also minus. Then 25 minus x squared is considered difference of two squares. So the square root of 25 is 5, and the square root of x squared is x. Then we have the sum and difference of two terms. Then we can expand the quantity x minus 5 squared is equal to the quantity x minus 5 times the quantity x minus 5. Then we rearrange. 5 minus x is equal to negative x plus 5. Then 5 plus x is equal to x plus 5. Then we factor out negative 1 out of the quantity negative x plus 5 to get the quantity x minus 5. Then divide or cancel out all common factors. So we're going to cancel the common binomial factor. X minus 5 divided by x minus 5, we have 1. Now take note, there must be no negative on the denominator. So therefore, we're going to put the negative 1 on the numerator or a line on the fraction bar. So we have negative x plus 5 all over x plus 5. We can rearrange the numerator and it turn into 5 minus x all over x plus 5. For number 8, we have 4x squared plus 11x minus 3 all over x squared plus 5x plus 6. Factor both the numerator and denominator. So for the numerator, that is a general trinomial in the form ax squared plus bx plus c, where a is greater than 1. So we can use the magic x. On the top of the x, we're going to have the ac. So multiply a, 4, and the c, negative 3. So it gives us negative 12. Then on the bottom, we have b, which is the coefficient of the middle term, positive 11. Then we're going to get the factors of negative 12. If you're going to subtract, the result is positive 11. So we have positive 12 and negative 1. Positive is the middle term, positive is the larger, negative is the smaller factor. Then divide both factors by the leading coefficient 4. So 12 divided by 4 is equal to 3. So we have the quantity x plus 3. Then negative 1 divided by 4 cannot be. So that is the lowest term. And take note, the denominator is the first term and the numerator is the second term. So we have the quantity 4x minus 1. So 4 is the coefficient of x and negative 1 is the second term. Then for the denominator, x squared plus 5x plus 6, that is also a general trinomial in the form x squared plus bx plus c, where a is equal to 1. So we're going to factor 6, whose sum is 5. So factor the first term, x squared, we have x times x. Factor of 6 is 2 times 3. If you're going to add 2 plus 3, we have 5, which is the coefficient of the middle term. Then divide or cancel out all common factors. So we have the common binomial factor, x plus 3 divided by x plus 3, that is equal to 1. Then multiply the remainings. So the result is 4x minus 1 all over x plus 2. For number 9, we have 4x squared plus 6x plus 9 all over 8x cubed minus 27. So first, factor both the numerator and denominator. And the numerator there is considered a prime. So therefore, we just copy 4x squared plus 6x plus 9. 4x squared plus 6x plus 9 is not a perfect square trinomial. Why? If you're going to check, the square root of 4x squared is 2x and the square root of 9 is 3. So 2x times 3, that is 6x times plus 2, it should be 12x. Now for the denominator, that is considered the difference of 2 cubes. So we're going to get the cube root of 8x cubed, that is 2x. Then we copy the sign or same sign. We have minus. Then the cube root of 27 is 3. Then to get the trinomial, we're going to square the first term 2x. We have 4x squared. Then the opposite of minus is plus. Then multiply 2x times 3. We have 6x. Then 3 squared is equal to 9. Then divide or cancel out all common factors. We have there the common trinomial factor. Same first term, same second term, and it should be same third term. So cancel 4x squared plus 6x plus 9 divided by 4x squared plus 6x plus 9, and that is equal to 1. So the result is 1 over 2x minus 3. For number 10, we have 9x squared plus 12x plus 4. All over, we have 6x plus 4. Factor both the numerator and denominator. So the numerator is considered the perfect square trinomial. The square root of 9x squared is 3x. And the square root of 4 is 2. If you're going to multiply 3x times 2, we have 6x times 2, we have 12x. So we have the quantity 3x plus 2 squared. Then for the denominator, we can factor out the common monomial factor. And the common factor on 6x and 4 is 2. And for the remaining factor, divide 6x divided by 2, we have 3x. 4 divided by 2, we have 2. Then apply the quotient rule, so we can divide or cancel the quantity 3x plus 2 squared divided by 3x plus 2. We have the remaining 3x plus 2 on the numerator because the exponent 2 is greater than 1. So the result is 3x plus 2 all over 2. Now take note, we cannot cancel 2 on the numerator and on the denominator because the numerator is a binomial and the denominator is a monomial. So that is the simplest form. Now it's your turn. Do it yourself. Simplify the following. Don't forget to comment down below your answers. Happy learning! Thanks for watching. Please like and share. And don't forget to subscribe on my channel and click the bell button so that you will be notified whenever I'm going to upload a new one. Maraming salamat!